Okay, so one thing we know about matrices is we can have something that looks like an equation with two matrices. So we have matrix equality. In order for two matrices to be equal, their corresponding entries also have to be equal. So I have two square matrices on the board right now, and even though some of the entries look different from one matrix to the other, we know that their values are really the same, so those are two equal matrices. The square root of 4 is really 2, 1/2 is really 0.5, so those represent equal matrices. And I think we'd all agree on matrix equality, the corresponding entries have to be equal. So that gives us the ability in a problem like this, we can solve for variables inside of our matrices if we know two matrices are equal. So I have, again, two square matrices, and they could be any order for matrices here, but I've got 3x and then 6, 4. And then I have x plus 1, 2, and 2y, 4. Look those over. Knowing what you know about matrix equality, what's an equation you could write to solve for either x or y? Bailey? Okay, you could look at the first row, first column entry in the first matrix. That must be equal to the first row, first column entry in the second matrix. So 3 equals x plus 1. Or you might see that x also appears all by itself. X equals 2. But if Bailey wrote 3 equals x plus 1, doesn't she know it right away, x equals 2? So to me, those are one and the same. But what that's showing is that no matter where x shows up in that matrix, the value of x then must be 2. Okay, so whether you use the first row, first column entry, or the first row, second column entry, you're going to get the same answer. Okay? All right, and then we could also solve for y. What equation will we write? 6 equals 2y. Y equals 3. Yeah, so just make sure you're picking things in the same location. All right? Pretty standard. And then solve equations like you would normally solve equations. If it's quadratic, then you would try to factor. Okay, the other operations, and these are pretty simple operations here, are addition, subtraction, and then also scalar multiplication. So a couple things to remember about adding and subtracting matrices. In order for you to be able to add and subtract matrices, it must be true that the matrices have the same order. And that's because we want every entry in one matrix to have a corresponding entry in the other matrix. That way we can add and subtract those entries. If their orders don't match, some entries won't have anything to add or subtract with, and then you can't do it. And then scalar multiplication, you're just multiplying by a scalar. A scalar is just a real number. So you use scalars in geometry to change the size of different shapes. You can make it larger by multiplying it by 3, or you can reduce the size by multiplying it by 1/2. And so we would just multiply the entire matrix by a number 3, well then every single entry in the matrix gets multiplied by 3. So on the next slide, what I'm going to do is I'm going to have you write down two different matrices. I've got a matrix A and a matrix B. And then under that, I'll have some operations like addition, subtraction, or scalar multiplication that I just want you to work through. It won't take us very long. We'll double check, talk about strategies, that kind of thing, so that you can practice these operations. So in my example, I'm going to say that matrix A is first row 4, 0, -3, second row -1, 8, 4, And then matrix B is equal to first row 1, 0, negative 1, second row 4, 3, 7. And then you are going to perform these operations. 2A and then also A minus 3B. If you are having trouble deciding how to start one of those, you can talk with the people at your table groups. What are you guys going to do for this? We're doing scalar multiplication. We're doing addition and subtraction.
Our college career and academy expo is now concluded. All sophomore students should be in their fourth-hour class within the next 5 minutes. Thank you for everyone's assistance and flexibility today. Have a great afternoon.
Okay, so you can look up at the board here and see if your answer matrix agree with mine. I'm just going to talk about what I saw as I walked around the room and what I would recommend coming up for your quiz or test. So these could be questions that I put on a no calculator portion of the quiz or test. I think that you should be able to do this without your calculator. For most of us, when we did 2 times A, we didn't show this middle work. Just so you're aware, this is what it would look like if you wanted to write a scalar times a matrix. I'm totally okay with that. I think most of you just wrote down the 2 by 3 answer matrix. You just multiplied every single term by 2. Okay, we got it. We're done. Okay, so I think on that one the answer is okay. I liked that as I walked around the room for this A minus 3B, I saw a lot of people who wrote down 3B. So that would be my recommendation to you on a quiz or a test. I know that I saw some people who were just, again, writing an answer matrix, and I totally agree with you. You have the mental capacity to go ahead and do that mental math. But if it's something that's going to be graded, I would recommend writing down that scalar multiple matrix so that if you made an error, I can see what numbers you were working with. So that would be my recommendation. So at least on this one, multiply all of B by 3, write that down somewhere, and then think about A minus that. Remember that if you're subtracting matrices, you'll have to subtract all the entries. Do you guys agree with my numbers over here? Okay. So that would be helpful to me when I'm grading, and helpful to you if you need to find mistakes. Okay. Moving right along, we're going to talk about matrix multiplication, which, if you'll remember from Algebra 2, is probably the most challenging of all the operations. And once you get it figured out, it's really not so bad. Again, this could be something that I would ask you to do on a no calculator portion of a quiz or test. Of course, you can do all these things in the graphing calculator, right? it would just require you to input multiple matrices. So you put in matrix A, then you put in matrix B, and then you call it to do different things, add, subtract, multiply, whatever. So matrix multiplication has a different rule. To multiply two matrices, they do not have to have the same order. The only thing that must be true is that the number of columns in the first matrix must equal the number of rows in the second matrix. So columns in the first must equal rows in the second. The easiest way, I think, to go about checking, like, is it set up for multiplication, and you probably saw this last year in Algebra 2, is write down the order of the first matrix. So the order of the first matrix is something like m by n. In order to be able to multiply the two matrices, the next matrix must start with n, and then we're going to say it's some n by p. We know really nothing about m, n, or p. Could they all be the same? Yeah. Could m and p be the same? Definitely. Could they be different? Sure. The only thing you have to do is make sure that the columns in the second, or columns in the first matrix match the rows in the second matrix. So those middle numbers have to be the same in order to multiply. Does anybody remember then, if you set that up, what is the order of your answer matrix? You take an m by n times an n by p. It's an m by p. So your answer matrix are going to be those outside numbers. And that could be really helpful for you just in terms of like organizing your matrix multiplication. Like how does that work? Okay, so I'm going to give you two matrices, and I set this up like some of the problems in the book where it'll say like A equals B equals C equals, and then it'll call on you to do things like find the product of A, B. If you, in your notebook, want to just write them down as two matrices getting multiplied together, that would be fine with me. So you might write down 2, -3, -2, 5, and 1, 4. The book might write them showing it like, oh, these two matrices right next to each other are getting multiplied. It might also just write them separate and then call on you to do like A times B or B times A. Okay, first thing I always do before I actually multiply the matrices is check that they can be multiplied. You don't want to start multiplying and then find out later that that wasn't even possible. So name the orders of each matrix. This first matrix is a 2 by 2, and the second is a 2 by 3. Can they be multiplied? Yes. The columns in the first match the rows in the second. And what's the order for your answer matrix? 2 by 3. So I always like to keep track of what my answer matrix is. So here's the test, and I'll give you like about 20-30 seconds with your small groups. Does anybody remember how you go about multiplying those matrices? So throw out some ideas with your groups. Maybe you'll catch on to something and you'll come up with the idea. How do you multiply those matrices?
Okay, so you just so you take your 2 times the multiply line and you make it add and bottom line and you average all together and you add it. And then take that the second row and you flip it and you take the negative 2 times the top line and your 5 and the bottom line and you add them together and that's your bottom line.
Okay, does somebody have a great way to explain to us how we're going to multiply our matrix?
I think I know that.
Olivia.
I got this. Okay. So you multiply, you take it. I remember like when you flip the first one sideways, so like the 2, you would multiply it next to like the 1, and the -3, we put like where the 4 is.
Yeah.
And then I think you multiply 2 times 1 and -3 times 4. I remember to like add down and have people on your spot. Yeah.
Okay, so you take the rows in the first matrix, and you multiply them by the columns in the second matrix, but you kind of have to do that little like rotating thing. Okay. So in this first matrix, your first row is 2, -3. Take the first entry in the row, multiply by the first entry in the column of the second matrix. And then second entry in the row, multiply by second entry in the column. When I multiply the first row by the first column, that gets me this entry right here, which is row 1, column 1. In my 2 by 3 matrix, I should have a row 1, column 2, and a row 1, column 3. Those will come from like what Olivia's talking about with this row. Now I have to multiply it by the second column. So do you like just, when you write that 2 and -3 right next to it, do you do it for all the columns, or do you just leave it out in the front? Do you remember? Like, would you, if you were going to say, like, I need to do that again with the second column, would you rewrite it to in the
Oh, no, I
just kind of like distribute?
Yeah, that's what I do.
Okay. So then, now you got to do, in the second column, it's going to be 2 times 0 plus -3 times 3. And that was the first row and the second column, so that's our first row, second column entry of our answer matrix. We still have one more entry to get in that first row, third column. So now we gotta do 2 times -1 and -3 times 7. Okay, ringing the bell. How do you get the second row of the answer matrix? You do the same thing with the second row. So now we're going to go back and we're going to pull out -2, 5 and think about distributing that. So I'm going to do -2 and 5 out here, and then we multiply it by each of the columns. So that would be -2 times 1 plus 5 times 4. That would be -2 times 0 plus 5 times 3. And then -2 times -1 plus 5 times 7. And then simplify. So my final answer should be -10, -9. Is this -23?
Yeah.
18,
15,
15, and 37. Okay, so let's have you practice one, see if you could do it on your own. So I'm going to give you one to multiply. Again, make sure you check to see if you can multiply it. No sense in doing it if it's not possible. See if you can multiply these matrices together.
Yeah.
Check with your group member that's been approved, see if you can find your error if you have one.
Will you change the order of your, when you flip it vertical, 3 is on top, negative. So like the first entry in the row, you see the first entry.
Okay, it's looking pretty good. You should check with your group member who has the correct answer. Make sure that you agree with that. Just one other thing, and I don't think you necessarily need to write this down, but at the end of your homework assignment, you will have some application problems where they describe some kind of situation to you. So in this particular problem, if you just kind of follow along, we'll kind of talk about like what's our plan for these. This table shows 3 different activities: basketball, jump rope, weightlifting, and then 2 different weights for 2 different people, 130 pounds and then 155 pounds. And inside that table is the amount of calories they burn for 1 hour of exercise doing those activities. So we have some information provided to us. Notice that when it's put in a table, it almost looks like a matrix already. So I might think about just copying that information into a matrix. So whatever information they tell you, think about it in matrix form. And in matrix, each row represents a different activity. Each column represents a different weight person. And then there's some other piece to the problem that they're going to talk about, and you'll have to decide, like, should I be adding matrices together? Should I be subtracting? Should I be doing a scalar multiplication? Do I want to do matrix multiplication? You'll kind of have to figure that out. So it says, a 130-pound person and a 155-pound person play basketball for 30 minutes, jump rope for 15, and lift weights for 30. How many calories does each individual burn? So notice that in this particular problem, I'm not doing the full hour of those activities. So that would mean I'm not burning that maximum number of calories, right? If we just talk about a 130-pound person who plays basketball, that's this very first entry in first row, first column. They would burn 472 calories in 1 hour. What if they only play for half an hour? How would you calculate their calorie rate? Multiply by 1/2, divide by 2, right? So if we're only playing for 30 minutes, that's 30 of 60 or 1/2. 15 would be just 1/4 of the calories get burned, and then this 30 would be another 1/2. So do you think you want to add, subtract, or multiply some matrices? Multiply. You guys told me you'd multiply 472 by 1/2, right? So then, once you kind of decide what's going to happen, this is a 3 by 2, 3 rows, 2 columns. You have really 3 pieces of information about the time that they exercise. So you could make one of 2 matrices. 3 by 1, 1 by 3. To multiply by a 3 by 2, which one do you want to make? 1 by 3. So I could decide, just in order for me to be able to multiply those, I need to organize that in a 1 by 3. And remember, if we were going to multiply them, then we'd kind of turn that whole row vertical. We want basketball, jump rope, weightlifting. So we would do 1/2, 1/4, 1/2. That way, I'll do half an hour of 472, a fourth for 590, 1/2 times 171, or 177. When I add them all together, that's my total calorie burn for my 130-pound person. And then I'll do the next column, 1/2 times 563, 1/4 times 704, 1/2 times 211. Add them all together, that's for my 155-pound person. Okay. So you'll just have to read the problem and kind of decide, like, what does the scenario call for? Okay, so you have homework assignment on your gold sheet. You can begin your work. We have about a little over 15 minutes. It's a nice chunk of time. If you need to talk to me about last night's homework, come up and see me. If you need to check it, I've got answer key up